Hey folks, today I'll show you how to check if the TV's LED kit needs replacing and guide you through the complete process of changing the LED kit. So, we're here with an LG TV. I'm displaying the models on screen for you, but this procedure works for many TV models, even from other countries, where the model name might differ by a letter or two. I'll list compatible models in the video description, along with a link to buy the same high-quality LED kit I'm using. This kit has an aluminum base and top-notch diffusers, just like LG's. It also comes with thermal double-sided tape for easy installation and better heat transfer to the TV chassis, which helps with installation and increases the longevity of the LED kit. Because it'll dissipate heat to the panel, which is a metal mass that can also be used for LED heat dissipation, thus significantly increasing the LED kit's lifespan. Also, folks, I'll show you how to check the LED current to prevent premature burnout. In most cases, it's necessary to do this check, and if needed, reduce the LED current. It must be done, or else the LED kit won't last long and will burn out early. So, how do I identify if the problem is in the LED kit? First thing, folks, I always clean the TV screen thoroughly then. And with the standby LED on, we'll press the power button. I won't turn it on yet, but usually the TV shows a logo in the center. This logo makes it easier to see the image when the TV first turns on. Even past the logo, you can confirm with the background and image info on the TV. So initially we need to see a background image, but we can only see it by applying lighting. The stronger and cleaner the light on the TV screen, the better it is for visibility. Another case is when a customer says the TV has sound but no picture. This happens when they turn on the TV and it gets a signal from a channel or HDMI or any source sending image and sound. The TV is actually displaying the image, but we can't see it because the LEDs are burnt out and not providing light. We can still hear the sound from the program though. So folks, how do we identify this issue? I'll now grab the camera, zoom in close to the screen, and turn on the TV to show this. Alright folks, I'm here with the TV off in standby mode. Now I'm going to turn on the TV. The image is hard to see through the phone camera, but I'll try to make it clear for you. Okay, I'm going to press here now, tapping to turn on the TV. At first, it'll be hard to see the LG logo appearing. I can see an image in the background, but I know it's difficult to make out. So what I'll do is use the remote to press the home button. Watch as an image appears. I'll press once, it's gone. Press again, it's back. Moving the camera closer, you can see symbols and text, like a guide of some sort. I'll press once, it's gone. Press again, it's back. One more press, it's gone. Another press, it's back. Folks, you can now see that the TV is generating an image. I'm toggling the home key, making the image appear and disappear in the background. Well, folks, this test gives us almost 100% certainty that the defect is in the LED kit. Now let's open up the TV to confirm and replace the LED kit as well. Let's start by removing the back cover of the TV. Just remove all the screws, no exceptions. Now, just to be thorough, I'll confirm if the issue is really in the LED kit. The problem could be in the power board, main board, or a bad connection somewhere. However, this extra check isn't really necessary because the initial test I showed you gives us almost 100% certainty that the issue is in the LED kit, which is common for these TVs to develop over time. I'll be demonstrating this procedure for those interested and for those who need or prefer to buy the tool I'm about to show. So folks, this is the LED tester. It also tests diodes and other components. How does it work? When it detects a closed circuit, it increases voltage from 0 to 330 volts. When current flows with this button, it'll output up to 40 mA, and in this other option, about 5 mA. Shall we test it? I always test with the highest current, which is 40 mA. So how are we going to do this? Now we'll remove the harness that connects to the backlight system, the LED lighting behind the display. Here we have the positive wire, which is red, and the ground wire, which is the return, in black. Let's put the ground probe here on the ground wire. The positive tip is here in red. Notice, folks, there's no circuit closure or conduction. I'll show how this test works with the new LED kit using just one LED bar. Here's part of the LED kit with 1, 2, 3, 4, 5 LEDs. I'll set it up to test and simulate the equipment's operation. If we reverse the polarity, it won't burn out, it just won't light up. Let's identify which is positive and which is negative. This isn't the right polarity. Let's flip it and the LED should light up. LEDs are on. The device is injecting current, showing 28 volts for these 5 LEDs. This tester shows slightly below the LED's nominal power, but indicates their voltage. All right, so we can see that this bar here is working normally. This is how the equipment functions. I'll leave a link to this equipment in the video description for those interested in getting it. Now let's start opening the panel to replace the LED kit. We've confirmed with 100% certainty that the LED kit is the source of the problem. To open the panel, folks, we'll need to remove some components from the TV. Let's get started by removing the speakers first. Let's lift to detach the rubber bushings and press the connector tab to remove the wiring harness. We'll do the same for both speakers. Now we need to remove the Wi-Fi card. Remember to organize the screws to avoid mixing them up. Next, I'll remove the IR sensor, also known as the infrared sensor. Let's remove the harness for the Wi-Fi card and IR sensor. Here's also the power and function buttons. For this, we have a connector with a locking mechanism. Lift the black part to remove it. While we're at it, let's remove the audio harness. Now let's remove the display's flat cable, the LVDS cable. We have markings for L, R, and orange and white colors here. When we put this flat cable back, we must follow this order or the TV won't display and might burn out. Now I'll remove it from the display board. Let's pull two latches and the cable. I'll position the cable so it's immobilized. We've secured the cable so it won't affect TV handling. Let's remove some screws, starting with the TV stand structure. After removing the TV stand, we'll take off this metal piece I call armor. It protects and helps dissipate heat from the buffer board, the display driver board. We'll remove all the screws from these two pieces. I'll also take this chance to remove the bottom screws. Now we'll remove the metal cover. Be careful. Remove it like this, folks. Like this. We'll minimize friction on the ribbon cable. I always remove it by pulling back and up, away from the brush and board. Now, folks, we must be very careful with these boards and ribbon cables. They direct image signals to the display and are quite delicate. We should avoid stretching, forcing, or bending these cables. The less we handle them, the better. However, we can't open the TV without touching them, so be extra cautious here. This is one of the riskiest parts when opening and closing the TV. Alright, we've nearly freed everything for display removal, but this TV has screws here too, holding the front black frame to the TV chassis. So we need to remove all these screws. Now, after removing these screws, we'll carefully turn the TV over with the screen facing up. All right, folks, let's move on to removing the frame. The screws we just removed allow us to separate the frame from the rest of the TV. We'll need a spatula for the sides and top. So the procedure I showed you was for the locks connecting the frame to the TV's metal chassis. I've done this around most of the TV except the bottom. I've done both sides and the top using that method. The bottom is already loose, so I believe everything is now detached. Just lift it up as you can see and the frame comes off in one piece. Now that we've removed the frame, it's time to take out the TV screen. For this, I'll use my homemade screen remover. However, you can also purchase the screen remover from the video description link I'll provide. Since this TV is quite large, you'll likely need 2 units of the screen remover. I'll link it in the description. 1 unit will cover about half the screen and the other will cover the other half. With 2, you'll secure one here, another there. Grip the base and lift the screen safely, just like I'll demonstrate with my homemade screen remover. Now, folks, I've chosen to leave the buffer board in this position. It's a technique we TV repair technicians may or may not use, but I prefer it to ease display removal and prevent the buffer board from hitting here when removing the screen, because this frame you see under the screen will stay in place. Only the display will be removed. When removing the display, the buff board might stick and hit these plastic edges. So I prefer to leave it like this for safety during removal. So how are we going to do this? We'll remove the buff board first. For removing the buff board, folks, we have rubber supports here. And we'll do it like this. We'll lift the rubber tip hook with our finger on both sides. Then we'll free one part of the buff board and then the other. All right, folks, it's now released. Now I'm going to peel off a bit of paint. I'm going to use a business card here, folks. It's very handy and perfect for this procedure. Plus, it won't scratch the screen. We'll put another here, but first we need to apply some tape. Now the screen is ready for removal. This, folks, is my homemade screen remover that I made. I bought silicone suction cups and PVC pipes to make my own DIY screen puller. But remember, I've linked the screen puller in the video description. You might need to buy 2 units for a TV this size. It's quite cheap and comes with larger, more flexible suction cups, which provide better grip and safer removal as they're more pliable and soft, reducing the risk of damaging the display. These ones, while made of silicone, are a bit rigid. So even with my experience, I must be very careful not to break the screen. I've linked the screen puller in the description. I'll buy it too and use it in the future for safer procedures. Well, folks, it's crucial, whether using the screen mount or whatever you're buying, to always keep the TV screen and suction cups clean. The suction cups must be in good condition, not dried out, or they won't securely attach to the screen. A small issue I anticipated is happening. Some suction cups will land on the support I placed on the buffer board. So knowing where the suction cup will land, I'll adjust the buffer board support to move it out of the suction cup's way. All right, folks, now I'll attach the suction cups, pressing carefully as I mentioned, without applying too much pressure. Done, I attach them one by one to avoid putting too much pressure on the screen. Now I'll lift it to remove the TV screen. On some TVs, the screen is glued to this frame, at least in parts. I don't think this one is, so I'll lift it, and if I feel any glue, I'll stop lifting right away and go back to cutting the adhesive to remove the display. All right, let's go. I don't think there's glue, so let's test it now. Great, folks. It came off safely. Now I've got a spot ready to place the TV screen. All right, everyone. The TV screen is now in a safe spot, over in the corner, with a cloth underneath. We're now looking at the polarized backlight sheets. Behind these sheets is acrylic, and behind that, we'll find the LED. Before touching the LED kit, we need to remove the diffuser sheet. It's crucial not to talk over this without wearing a mask, and we must use gloves to remove these films. Place them somewhere clean, avoiding contact with dirt, grease, or anything that could stain them, as they generate the TV's white light and color image. If stained, these films will affect the TV's color and lighting. All right, let's start. I don't need gloves yet to remove this frame, so I'll begin with the spatula. We can clearly see the latches here. They're quite visible. We'll be unlocking all these latches now. Now that we've removed the frame, let's remove the protective films. We'll use a fabric glove. I prefer fabric, and the glove must be clean. I wash these gloves regularly so I can reuse them. Keep gloves clean. Dirt falls during opening, sticking to TV parts. I use air to remove it, avoiding pressing dirt onto the panel. Since there are multiple films, we'll remove them all together to maintain order for reassembly. I grab the acrylic from underneath, above which are the film layers. I'll remove the entire set of films and acrylic together to keep everything organized and make the job easier. To prevent the films from falling due to wind or such, I don't have AC here. I'll place a clean cloth on top, secured with tape. Now, folks, let's remove the clips holding these films in place. For this one, it's easy. We'll just rotate it about 45 degrees to remove it. Don't break these guys. We'll reuse them. They're not sold separately. Turn it carefully, as there's some friction when rotating. So we need to do this. A back and forth motion to unlock it and start spinning. This increases the chance of removal without breaking. Some might have tape holding them back, as you can see. So let's remove that tape. To release the lock, as forcing it might break it. I know my limits. but it's best to remove the tape first. I removed it all without breaking anything. Now folks, let's remove the diffusion sheet. We must be careful, as each LED diffuser holds the sheet in place. So we need to remove it gently to avoid tearing or breaking. Why do I mention breaking or tearing, folks? Normally this material tears, but heat from LEDs can make it dry out over time. So instead of tearing, it might break and become more fragile. That's why we need to remove it very carefully. I remove it by making these movements, releasing one side of the diffuser and then the other. Then I remove each LED bar row by row. All right, I've released them all. Now let's remove the diffusion sheet. At this stage, it's not necessary to use gloves. So I'm going to take off the gloves. This also prevents contaminating the gloves for the next step when we assemble the TV. Notice, folks, that the LED kit is clearly burnt out here. Take a look. We have a sign of a broken circuit trace here. There's another broken trace in LED here. And another one here too. So folks, now we just need to replace the LED kit. Check the current if necessary. It's controlling the current, decreasing it. Usually needs to be lowered a bit, and then everything's okay. Just assemble the TV. Now let's remove this LED kit. Note that we have some clips here securing, at least at the top, each LED bar. So we need to remove these clips. We'll use pliers for this. Now let's remove the wiring from each LED bar. Note that the connection is quite simple. There are small locks we'll press to close. We'll use a tool to lift the connector from the LED bar. You can remove these with force and technique, or use a heat gun to help with removal. I'll start without using my heat gun. If needed, I'll get a heat gun for removal. Let's begin. I'm pulling now, and it's coming out easily. This LED kit is aluminum, so it's high quality. What we'll use will match the original quality. Some originals aren't aluminum-based, reducing lifespan. Lack of heat dissipation and transfer from the LED bar to the chassis. We'll remove the old tape to make room for the new LED kit tape. Now folks, we're going to install the new LED kit. To help with alignment, we'll use these AI pins to center the new LED kit. I'll start centering at the bottom and work my way up with the others. We need to space these pins evenly in the holes as they might not fit perfectly. To use as a template, I'll check if the lock hole aligns with the existing hole. And yes, folks, it's a perfect fit. We'll repeat this same process for the remaining LED bars. All right, everyone, the entire LED kit installation is now complete. Now we'll test to see if the lighting is working. For safety, we'll disconnect these cables to prevent damaging the LVDs and TV image parts. This is just to avoid accidents. Let me raise the camera. Not sure if you can see clearly. I've unhooked these cables to prevent shorts with metal parts. We'll move this one too. We'll put this other one behind the board as well. Now we can safely conduct a test. Let's grab the power cable. We'll connect the LED cable here. Let's turn on the TV and see if it powers up automatically. If it doesn't, we'll need to install the sensor, folks. No need for the sensor. It's armed automatically. Notice the LEDs are lighting up now. These LEDs provide excellent illumination. All right, folks, I'm going to test if we need to control the LED current. How will I do this test? I'm going to do a quick calculation. It's pretty simple. I'll show you how it's done. Let me set everything up here. Now, TV LEDs usually work individually at 3 or 6 volts each. We don't need to measure all of them, just one bar or even one LED. I'll test on one LED bar here. How will I do it? First, I'll count the LEDs. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 LEDs. So if we have here, if the LED voltage is 3V, 3x9 will give 27V. If it's 6V, then 6x9, 6VX9 LEDs will give 54V. So for 3V, 3x9 LEDs, 3VX9 LEDs gives 27V. For 6VX9 LEDs, if it's 6V, it'll give 54V. All right, folks, let's test this with the multimeter. I don't calculate directly with current. If adjustable, I set it first, and it works by adjusting the voltage to the LED's max, which we know is the LED's nominal voltage. We'll also achieve the right current flow. Some TVs have a wide adjustment range, others don't reach what we need. With a short range, we can't adjust properly, but we get close. Now I'll show you how to do this check. Alright folks, I'll be using this multimeter here. This multimeter has an option to set the voltage scale. Since we might reach 54V, I'll set it to 200V, which gives us a margin to measure the voltage. Now I'll bring my series lamp closer, but I'm not using the series lamp here. I'll turn off the power supply to switch on the TV and also turn it off to perform this test. So let's get started. Positioning here, we have the positive and negative poles. I'll hold it by hand as I can't secure the multimeter probe. I'll activate the backlight, turn it on, set it to record peak voltage, then turn on the TV to see the max voltage. We've got a max voltage of 52V, folks. Each LED works at 6V and won't be, folks. It's not necessary to regulate, as the max it could reach is 54V and it's hitting 52V. So there's no need to adjust this TV. This means that besides this LED kit's great quality, it also, folks, accepts the right current. It regulates with the power board automatically, recognizing the proper current for adjustment. So besides its quality, it provides safety and eliminates the need to adjust the power board. With this, folks, I know I can assemble the TV, and this LED kit will be highly durable. It meets all the high durability criteria, so we won't have issues with the TV returning with LED problems under warranty. It'll likely last as long as, or longer than, the factory one, as factories sometimes run LEDs at 100% power. In this case, it's not reaching 100%, but slightly below. This will help a lot with the LED kit's lifespan. It's been on for a while and I'm holding it. The temperature is quite low, folks. It's not overheating, so we know it'll last a long time. Now we just need to reassemble the TV and do the final image test. Alright, I've given it a blast of air. Now I'll put the glove back on to start reassembling the TV. Folks, I've noticed that the LED diffuser in this kit is larger than the original. That's actually good, but it'll make installing the diffusion frame quite challenging. What we'll need to do here, folks, is enlarge each hole in the diffusion frame. It's going to be quite a bit of work. This will take skill and patience, folks, but we've got no choice. It's either do this or force it in, which I don't recommend. I prefer cutting it to size for a more precise installation. Problem solved. I widened each diffuser hole. It was work, but the template saved time. The original kit had smaller diffusers. The new, larger ones improve light uniformity. The frosted sheet wouldn't fit through the smaller holes, so I had to widen them. I'd place the new diffuser over each hole, trace it, then cut with a knife. I realized it'd take too long, so here's what I did. I made a mold using enameled copper wire, shaped it to the lens size, inserted it into cardboard, and glued it. I made the mold exactly the size of the diffuser. Then I placed the foil on a glass table, put the mold on it, and cut directly with a utility knife, one by one, until I had all of them. This saved me a lot of time. Making the mold took a bit, but it was worth it. I'll keep it for similar projects in the future. Once done, the fit was perfect. The foil fit perfectly and locked into each diffuser. Now let's move on to the assembly. With the assembly, the next step is to put the clips back on. We'll insert the clips one by one. Now that the clips are installed, I'll give it a blast of air and put the films back on. I'll leave the power cord plugged in to test the lighting and check for any stains or dirt. The lighting looks perfect, except for one abnormality in this area of the films. I think it's due to the heat from the LED burning. There's a light spot here, which was already on the film when I opened the TV. This spot will remain, unfortunately, as TV films aren't sold separately. Still, the result will be good and worth it for the customer. We just need to explain this. Now I'll give it another blast of air. Let's put on the bottom frame now. First, I'm going to clean this frame. I'll clean it with a brush to remove dirt before fitting the screen to prevent it falling on the film. So I'll clean it here, a bit away from the TV. After that, we'll give it another blast of air. I've noticed some dirt between the films, so I'll make a small opening here to remove this dirt. With the dirt removed, let's put the TV display in place. Always check if the display is inside the frames, below the raised edge. If it's on the edge or corners, forcing it will break the display. The display edges are very sensitive, so be extremely careful here. It must be fully inside the frames, especially at the corners. So I always do a thorough check to avoid breaking the display. If the TV display breaks, repairing the TV becomes unfeasible. Alright, with the display in place, I'll remove my glove and position the buffer board. With the buffer board installed, let's wipe the screen and attach the front frame. With the front frame fitted, I'll now turn off the TV. I'm going to do an image test now. Let's carefully lift the TV. Now let's connect the flat cables. These cables must be securely connected. Always check for perfect alignment to avoid damaging the display or main board. Position the connector correctly before lowering the latch. With connections made, let's test the image. All right, we have a picture. Let's wait for more details to appear. We'll check for lines, bands, or image defects. There you have it, folks. The image is perfect. Now let's proceed to open the TV. That mark is just ceiling light reflection from an LED bulb. Got it, everyone? The TV image is flawless, no imperfections. With good uniform lighting, I always do this check before continuing with the TV assembly. There's a strip here where the film was affected by heat. But it won't be too noticeable or affect image visibility. All right, let's move on to the rest of the assembly. My workbench is large. This TV is so big that even my large bench feels small. These are the screws we'll use, folks. Larger ones go at the bottom. Oh, I almost forgot to show you how to reduce LED current if needed. Let's do that now. First, use a multimeter to measure the max voltage from the harness. We'll record the peak voltage shown on the multimeter. Let's move the multimeter closer so you can see better. Okay, let's turn on the TV. Turning on the TV now. And we're seeing 261 volts here. As we measured before, an LED bar supports up to 54 volts, reaching about 52 volts. We know this TV doesn't need that much, but we'll sum up the voltage of these LED bars. There are 5 LED bars. Let's count. 1, 2, 3, 4, 5. So it's 5 times 54 for the total. Let's do the math. All right, 5 times 54 gives us a maximum voltage of 270 volts. We know the TV can handle up to 270 volts, so no adjustments are needed here. But if your TV exceeds 270 volts, you'll need to remove the power supply board. Before removing it, let's discharge this high voltage capacitor. I'm using a microwave lamp to discharge it, but you can use a resistor. Or buy a specific tool for discharging capacitors. I'll leave a link in the video description. Let's analyze the backlight circuit, the lighting system. We see it's powered by this harness. Let's look at the back and trace the circuit. Folks, I've likely spotted where current reduction happens, this resistor bank. Let me double check. That's right, the current reduction occurs in these resistors, a resistor bank. These R-sense resistors ground the MOSFET source and send a signal to the backlight IC driver. So how will you reduce the current? You'll remove any resistor from any position here. Not these, this one's separate, but these are included. See, 1, 2, 3, 4, 1, 2, 3, 4. These 8 resistors are part of the R-sense. So folks, removing any resistor from any position here will reduce the current. Gradually remove and test until you reach the maximum voltage of 270 V. If it's below 270 V, you've reached the proper regulation. Don't remove too many resistors or reduce current too much, or the TV's LEDs won't work properly. Why? Because it'll be out of the R-Sense's adjustment range, okay? So keep removing gradually and testing. If it stops working after removing one more, put it back and you're done. You can't reduce it further than that. Reduce the current while monitoring the voltage. When voltage is below 270 V, you've reached the ideal regulation to avoid burning out the LED kit early. Now let's proceed with the final assembly and testing of the TV. Bye-bye. All right, folks, there's the TV in full working order. This is the result, folks. You can achieve this too by following the step-by-step guide I showed you. If you prefer, you can reduce the LED current even when it's below 270 V. This will extend the lifespan even more, but when it's below the limit, the durability is already good and acceptable. The TV will last a long time. Don't reduce it too much though, as we'll lose some color enhancement and image brightness. I always try to balance quality and durability as much as possible. It's up to you if you want to reduce the current more to increase durability further. Well, folks, this is the result. The only normal thing left in the lighting is the mark of the polarized film, the PMA film, which was this mark here is due to overheating of one of the LED bars, which caused sparking and excessive heat. The heat affected the film, leaving a slight mark, but it's barely noticeable. I'll explain this to the customer, and I'm sure they'll understand. I've even recorded a video proving this, which I'll show to the client for better understanding. My clients know my work and trust that what I say is the absolute truth. So that's it, folks. This is the tip I'm sharing with you. Remember, I'll provide links for tools like the screen remover, capacitor discharger, LED tester, and LED kit. I'll leave these links for you to purchase these items, both for import and local purchase here in Brazil through Mercado Livre, and for other countries, for those watching from abroad. If you want to get these tools and materials to maintain this TV, I'll also provide a link for direct import from China, where this TV's LED kit is manufactured. This LED kit is high quality, but you might need to widen the holes for the LED diffusers on the diffusion sheet like I did. You might be lucky and your TV panel already has wider diffusers, so no widening needed, okay? It's worth it though. Great TV, top image, sound and features. Maintenance is worthwhile. Folks, if you enjoyed this, please like and share the video with friends and fellow techs. Hit the bell for new video alerts, and most importantly, subscribe to the channel, all right? Welcome to all new subscribers, and best of luck to you all. If you have any questions, feel free to leave a comment, and I'll do my best to respond to everyone, okay? Good luck, and see you next time.